Morning. Today I got something a little different. A friend of mine came by over the weekend and brought me a Fisher 400C tube preamp. Let's tilt this down so you can get a look at that. He rebuilt it, replaced all the capacitors, and said some mods had been done to it before he got it. But he said he's not getting signal through on one channel. Says he checked all the tubes and believes he has a switching problem. So let's get this thing set up and take a look at it and see what it's doing or not doing. Okay, so I'm taking the signal out of my signal generator here, going into the preamp, and then coming out, and we're going to go into the distortion analyzer and into the scope. Now normally my distortion analyzer is set up to look at my dummy loads. And for this, we're going to go directly in here, so I'm going to take the leads out to go to the dummy loads. I'm going to put these adapters on. Now I'm pretty sure I've shown these before, but these are just BNC to phono. And take the preamp output and go into the distortion analyzer. Now we're going to turn that little guy on and see what we get. Okay, starting to warm up, and we only have signal on the left or channel A. Here's the distortion's fairly high too. The tube's still warming up. Okay, so we're gonna have to do some signal tracing and see where the problem is. Okay, so here's a partial of the schematic. Now we're going to be tracing through these tubes. We're not going to worry about the preamp tubes right now. We're going to start up here. The preamp tubes are just for the phono, mic, and tape head, where you need additional stages of gain. Fortunately, these are very simple tubes. These are just twin triodes, either 12AX7s or 12AT7s. And we're just going to trace our signal through. Okay, so our signal for what we're looking at is going to start right here at V5 on pin 7. That's the grid of the tube. That's where the input is going to go in, and they're taking it off the cathode here at pin 8. So we're going to look and see if we have signal going through there, and if we do, we'll move on to the next tube and so on. Okay, so now I'm going to want to take a look with a scope probe. Alright, so I'm going to plug a probe here into channel 1. It's very important when you're probing tube amplifiers that you turn your input coupling to AC. This will put a capacitor in line and block any DC from getting into your oscilloscope input. Considering the high DC voltages we encounter in tube amps, this is a must. The other thing I do is I connect a ground here to the amplifier here, and that way I don't need to use that stupid little wire for ground that comes off of here and constantly pulls off and causes all kinds of havoc. So what we're going to do is we're going to signal trace through here and see where we're losing our signal at. Now these preamp tubes are only used for the high gain inputs, such as your phono, your tape head, or mic. These need additional stages of gain, but we're going in the aux input and losing it, so we're going to start right here. As our aux inputs come through, go through the wafer switch here, and then they come out and go into our tubes. So we have an input going into pin 7 on this tube, and it's coming off the plate here at 6 and going to the next stage. So we want to make sure we have signal at 7, coming out at 6, and going into the next twin triode over here at pin 7, and coming out in this case off the cathode at pin 8, because this is a cathode follower, very similar to an emitter follower in solid state amps. So let's start here. We got to go to V5, check pin 7 and pin 6. Right, V5 is this tube here. They count from the bottom of the tube socket clockwise, so we go 1, 2, 3, 4, 5, 6, pin 7, and we have signal. Okay, so let's see what we have at pin 6. We've got plenty of signal at pin 6, so that's going to take us to our next tube. We're good here through V5. We need to look at V6, pin 7, and pin 8. Alright, V6 is directly off to the right, and it's going to count out 1, 2, 3, 4, 5, 6, 7. And we have our signal going in at 7. Then we want to look at the cathode at 8. And here we have a lot of nothing. Okay, so what we're going to want to do now is take some DC voltage checks and see what's going on with this tube, because there's something wrong here. Okay, so according to our schematic here, we're supposed to have 270 volts coming in pin 6, 145 at pin 7, 153 at pin 8. So let's see what we have at pin 6. 309 volts. It's fairly high. Pin 7, 196, also high. And pin 8, which is our cathode, we have nothing at pin 8. Okay, so if we look at what we had 300, 195, and nothing. This tube does not appear to be conducting. So I'm going to have to turn this thing over. We'll take a look at it. Okay, so I've got this turned over, and we're going to pull that tube out. And, okay. Alright, so my friend said he checked these tubes out, and I can guarantee you this tube is absolutely dead. Looks like it lost vacuum. That's usually what happens when you get this white crap around here. But this tube is no good. Now it's a JAN 12AT7. JAN stands for Joint Army Navy, back when the military used to actually use tubes. So I'm going to replace it. If you look down here, it looks like the knobs have been replaced with knobs from a Marshall guitar amp. So I thought it was only fitting to put a Marshall branded tube in there. So let's pop that in. And then we're going to see what we get here. Okay, so I put the tube in, and let's see what happens. There we have it. Now we have good signal. Interestingly, let's take a closer look here. If you look, now our right channel has far lower distortion than our left. So I am going to try changing out that same tube in the left channel. Let's see which one that is. It says it's V3. I think this is V3 here. All right. That clipping you see is just the range, the auto ranging from the distortion analyzer. That's already looking better. So now we are looking more at, wow, 0.01% instead of 1% distortion. So, looks like this thing's working okay. I decided to break out the tube tester because I was curious why that one tube dropped the distortion by a factor of 10. And testing this tube, it appears to be a really good tube. Has no shorts, no grid emission, even passed the life test. So, a tube tester is a good tool as far as it goes. The only way you really know if a tube is going to work for you is in the circuit that you're testing it for. Now, I've never had one test bad that worked good, but I have had them test good that did not work properly in the circuit I was testing. Okay, so in closing, what I'd like you to take away from this video is listen to what people say. I mean, they brought you their device for a reason, but trust but verify. My friend said he tested all the tubes. It's obvious that that one tube was just shot. Very interesting about the other tube though, because when I changed it out, we dropped our distortion by a lot, and it just goes to show you, you can't always trust your tube tester. You really need to find out what's going on in the circuit under test. And the only way to do that is to test it. See what the distortion is. See what the waveform looks like. See if it's passing signal at all. By signal tracing and voltage checks, we were able to hone in right on the problem. And after that, by use of the distortion analyzer and changing a tube, we were able to drop the distortion drastically in that one channel. So I guess that's all I've got for now. And again, I want to say thanks. I hope you enjoyed the video, and I like giving back to the community that has given me so much. Thanks a lot. Have a good day.